So in the previous class, we discussed DC machines. Under DC machines, we completed DC generator. So the DC generator purpose is it's convert mechanical energy to the electrical energy. Now today we are going to discuss about DC motor. The DC motor principle is when you are giving electrical energy, it will convert to mechanical energy. So in the DC generator, mechanical energy to electrical energy. In the DC motor, electrical energy to the mechanical energy. In our domestic purpose, we all use AC motor. So to pump the water from the ground level to higher level, we use the AC motor. We are giving AC supply, single phase AC supply, then the motor will start and the water will move from lower level to higher level. And when you are giving supply as a DC supply, it is a DC motor. Then where we are using this DC motors is we are using steel plants, elevators, printing presses, and many other places we are using DC motor. In our toy cars are there. They will use the battery as a electrical supply. That battery will give you energy to the motor and that motor will rotate. We are also used this DC motor in cranes. There are many applications are there for DC motors. Objective of studying these DC motors to understand principle and operation of DC machine. The main objective of learning this DC motor is to understand the principle and operation, how electrical energy will be converted to mechanical energy, and what are the different types of motors, how we are controlling the speed. So all those things will be discussed in this subject. Let's start discussion on DC motors. So as I mentioned, DC motor, it will convert electrical energy to the mechanical energy. The input is electrical, that means voltage and current. Voltage and current, that is P is equal to V into I. And the output is the mechanical energy, which is having the analogous to voltage and current. We can have torque and angular velocity. Torque and angular velocity. It's like a black box. It's like a black box. When we are giving input as electrical energy, the output is the mechanical energy. That black box is nothing but a DC motor. Coming to applications, we use this DC motor in steel plants, paper mills, textile mills, printing presses, cranes and excavators. So these are different places where we are using DC motors. Coming to advantages, high starting torque. It is having high starting torque. Because of this application, previously in the electrical traction, we used the DC series motor. Because of high starting torque, we used in traction applications. The speed controlled over a wide range, below and normal speed. We can control the speed of the DC motor very easily. There are many methods. In further classes, we are going to discuss those methods, how we are controlling the speed of the DC motor. Easily start the machine and you can easily stop the machine, and reversing and acceleration. So everything is possible. Increase the speed, decrease the speed, accelerating, reversing, quick start and quick stopping. And there are limitations for this also. So the limitations are high initial cost. So high initial cost and increased operation and maintenance cost due to commutators and brushes. DC motor is nothing but the construction and working. The construction wise, it is very similar to DC generator. In fact, a DC machine is nothing but both generator and motor. It can be act as a motor and it can also be act as a generator. That's why you can use the same construction where we are discussed about DC generator. The same construction will be here. The DC generator, the commutator, brushes, all are there. To maintain those commutator and brushes, it is little bit cost. So the same thing we are here. Now let's discuss about the principle and operation of a DC motor. The main principle is whenever the current carrying conductor placed in a magnetic field, it will experience a force. I am repeating. Whenever the current carrying conductor placed in a magnetic field, that conductor will experience a force. If I have one magnet, if I bring another magnet in between, those magnets. If I have one magnet and if I bring another magnet very close nearer to that magnet, between those two magnets there may be a force. That force may be attractive force or repulsive force. From this we can understand, when the two magnets very close to each other, or then two magnetic fields are very close to each other, there is a force existed between. The same principle will be used in the DC motor. That force can be given as F is equal to BIL, where B is the magnetic flux density, I is the length current flowing through the conductor, or L is the length of the conductor. So the direction of force, the magnitude, and everything will be explained in electromagnetism lesson. That link will be given in the description, you can watch it. So if you see here, a DC motor is an electrical machine that converts electrical energy into mechanical energy. The working of DC motor based on the principle that when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. The direction of force is given by Fleming left hand rule, and this magnitude is equal to F is equal to BIL, where B is equal to magnetic flux density, I is equal to current flowing through conductor, where L is the length of the conductor. So the direction of force will be observed by using Fleming left hand rule, and the magnitude will be calculated from the formula F is equal to BIL. Fleming left hand rule is explained here. This is the north pole and this is the south pole. The magnetic lines are from north pole to south pole, and this is the conductor carrying current in this direction. So the direction of current will be in this way. The magnetic lines are in this direction, so the magnetic field will be in this direction. If you place middle finger of left hand is in the direction of current, your forefinger is in the direction of magnetic field, then the thumb will give the direction of force. If you are using your left hand rule, this is the thumb, forefinger, and this will be the middle finger. If you put your middle finger in the direction of current, forefinger in the direction of magnetic field, then your thumb will give the direction of force. So if you see, the current is in this direction, current in this direction, and magnetic field in this direction, then the thumb direction is upwards. That means the conductor will experience a force upwards. If we use another conductor here with the opposite polarity of current, that conductor will experience a force downwards. Okay, I will show this video, you can understand better. If you see here, this is coil, this is a magnetic pole, north pole, this is north pole and south pole. The magnetic lines are in this direction. So if you see, coil is in this way, the current direction is in this fashion. So this is the magnetic lines. Commutator with two segments. This is the coil. The current direction will be in this direction, I. The magnetic field is in this direction, B. So I can represent this current direction as cross mark. Why? Because that is into the board. Direction of force will be upwards. the upward force on this conductor and downwards force in this conductor. Now the conductor will start rotating in this way. So the brushes are stationary and the commutator segments are only rotating. You have to understand here. If you observe in this video, the conductor will start rotating with this direction of current. This is the upward direction and downward direction. The force will be in the red mark. So whenever we are giving supply, due to that force existed between this north pole and south pole, the conductor will start rotating. This blue color one is two segments of commutator. So this side conductor, the right side conductor will experience a upward force, and this left side conductor will experience a force on downwards. So with these two forces, the conductor will start rotating. If you see at this position, the magnetic lines linked to those conductors are zero. That's why in this position the torque is zero. So when start rotating in this fashion, if the conductors at this position, all the magnetic flux lines will be linked to these two conductors, then the torque existed or the force existed between the poles will be high. Okay, in this way we can understand the principle and operation of a DC motor.